Oh, the countdown got exciting. All right, so this is calculator test number 7, number 12. Make sure your calculator is handy. And our customer paid $53 for a jacket after a 6% sales tax was added. What was the price of the jacket? So, guys, I mean, you all shop, so maybe you could deduce your way to the right answer, but this is technically a really easy question, so make sure you get it right. When you tack on percentages like tax or you increase the price, you're taking all of the price plus the additional percent. So 6% plus the original 100%, we'd write as 1.06%, right? So 1.06% times whatever they charged for the jacket came out to $53. So if you think about algebra, how would I solve that? I would divide by 1.06. Now, definitely not the only way to get this question right. What is this, by the way? Yeah, I should find the right page. Yeah, so it's $50. For a lot of kids, they just pretend like it was $50 and then they tack on 6%, whatever way they know how, and they come up with the right answer that way too. That's fine. But obviously setting up an algebra equation, the reason we keep hemming and hawing over, well, we don't hem and haw. Basically, your math teachers make you set up algebra all the time because it's quicker. It's like you don't have to question yourself. All right, number 13 is Teresa's running speed and time. And this is her time versus her actual speed that's going on, not distance. So Teresa ran on a treadmill for 30 minutes of her time. Her speeds are shown, blah, blah, blah. According to the graph, they did it again, which is not true. And I can guarantee you the first time I did this question, I probably skipped right over the word not. So they didn't underline it, which is part of the reason I didn't skip over it. And for some reason, capital letters make me skip things. So when I see not show up in a SAT question, circle it, box it, do something to it, because you got to remember. So, is it not true? This is what we're looking for. Teresa ran at a constant speed for 5 minutes. It's a little hard for me to read the graph, but I think right here they're referring to the constant speed part, and that goes from 5 minutes to 10 minutes, so that would be true. That is a true statement, which means I'm not going to select it. So, next one, Teresa's speed was increasing for a longer period of time than it was decreasing. So let's investigate that a little bit closer. So this is an increasing speed moment. So that's for 5 minutes. And then here's another increasing speed moment that goes from 20 to 25. So another 5 minutes. So she was increasing speed for 10 minutes. But I don't think this one's true, guys, because if my pen will stop doing something weird, I will point out to you. There we go. All right, this decreasing chunk here goes from 10 minutes to 20 minutes. So that's, oops, not that. It's a 10-minute section, and then from here to here is another 5 minute. So she's decreasing speed for 15 minutes, which means this is the not true statement. So that's the answer we need to select. So people who just are joining us, that was a question where they snuck in the word not. I swear they're like gunning for me when they do that because I screw it up every time. But it's not true. Yes.
I only looked at the one line, so make sure you guys remember to combine all of this.
Right. I know. Isn't this fun? This is all like, man, you're having like deja vu moments and you're like thinking about all the goofy things you did. And this is a part of tutoring that a lot of kids like never get a chance to experience. So it makes me kind of sad because this is the most effective way to prepare for an SAT is for you to take it and then go over it ideally with someone who really, really knows what they're talking about. You guys are stuck with me. And then we can kind of point out like, oh man, I should have done this. And it's one of those self-effacing moments like it's really awkward to point out all the things you did wrong. Like you don't feel great about it, but it is a good learning experience. So that's the good thing. Some kids just keep taking SAT tests and they never look at their results. I do not understand that. I'm like, don't you want to know what you did wrong? They're like, no. I'm like, well, are your scores going up? Well, no. I'm like, huh, okay, cool. All right, number 14. Oh, they snuck a geometry question in. There is actually a little formula somewhere on your formula page that talks about angles of a polygon, I think, is on that formula page. Do you, just out of sheer memory, do you guys remember what the interior angles of a quadrilateral add up to? It's 360. And if you don't remember it, I'm real certain there's a formula on the front. Let me look, just so I don't lie to you. Oh, okay, I lied to you. Yeah, it's not there. So you're supposed to know that. All right, quadrilaterals, interior angles add up to 360. So these are all the same angle. So 45 plus these mystery x's, 3 of them, adds up to 360. Y'all have a calculator, so you're going to just Solve for x. So 360 minus 45 divided by 3, I think is 105. Now, I kind of gave you guys a heads up about, they never tell you this explicitly because they get into trouble. This is still test 7 from yesterday if you still have that one, but you are welcome to grab another. That's the full test 7 with English too, if you want that. Judging by the picture, like I knew those angles were not going to be like 45. And it's not a great way to start deducing questions, but at least you could eliminate that if you were just flat out guessing for some reason. All right, words, I gotcha. So 50 1-cent coins. Yeah, those are known as pennies, but whatever. 50 1-cent coins were stacked on top of each other in a column. The column would be approximately 3 7/8 inches tall. At this rate, which of the following is the closest to the number of 1-cent coins it would take to make an 8-inch tall column? So remember, guys, you have a calculator on this test. So fractions are like the bane of your existence. 7/8 is kind of a nice decimal. If you'd rather write that as 3 point whatever, go ahead and do that. What is 7/8 as a decimal? Yeah. So 50 coins makes that tall of a tower. And you just have to watch your labels on proportions, but we're all in inches and coins, so we're good. And then they want to know how many coins would you need to make an 8-inch column. So then I'd cross multiply and divide that. Now, can we cheat for a moment? Let's say I was really short on time, like so short that I couldn't even touch my calculator for some reason. Do you guys see a relative relationship between this and this? This is like double-ish, right? Like it's 4-ish to 8-ish. So we're going to like double-ish it. Just keep that in mind. What's it come out to? What'd you get?
103.
Well, and look closely. It says, which of the following is the closest to? So it's not going to be exact. I don't know why they did that. I have no idea. Like, I kind of thought they meant to put this question on the no calculator part. But are we on the no calculator part? No, okay. Just had a moment. Like, if I was a test writer, that would have been a really good question for the no calculator part, because you still had to understand how proportions work, but you would be testing the child's number sense, which would make more, well, I mean, whatever. If you have a calculator, this is a really stupid question. But whatever, I'll take your point. All right, moving along. Have fun. So we have, it's kind of a system. They want you to add up a plus b at some point, and we often find that when they ask questions that way, that shows up in your math somewhere, but we don't really need to freak out about that right now. Can you guys do a little solving for me? What is b if you kind of multiply by 2 on both sides here? B is 20. So if you throw that into here, you have a minus 20 equals 12, so now you can find a. That's 32. And if b is 20 and a is 32, what's a plus b? 52. Now, I did notice they put 32. Jerks. They did that on purpose. Nice. Sorry, SAT, but that was a jerk move. Okay, so moving on to 17. We have, oh look, a linear equation. One of their two favorites. It's either linear or quadratic. I'm sure you've noticed this by now. So this is kind of sort of in this form, y equals mx plus b. They have it a little backwards, so if that bothers you, you can rewrite it as 1.50x plus 1999. And can you remember how linear equations work, guys? The slope is referred to as a lot of things in math, but the most common thing is that this is a rate of change. And then the y-intercept, like literally when you're graphing a y-intercept, it's where you guys start graphing the line. But in word problems, you want to start interpreting y-intercepts as the starting points. Because algebraically, or starting point, I should say, not points. Algebraically, a y-intercept is the value you get when you plug in a 0 for your independent variable. So in like real life problems, if nothing is happening, that's like the starting point of the math problem. So I should probably do some reading because there's words here. The equation models the total cost that the company charges a customer to rent a truck for 1 day and drive X number of miles. So the total cost includes a flat fee blah, 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 y-intercept. What does the y-intercept of the graph represent? So basically this is a vocab question. They want to know that you know who the y-intercept is, which is 1999. So obviously it's either A or it's C. And does 1999 represent the flat fee of 1999, or is it a charge per mile? So per is synonymous with rate of change. So this is a slope question, and this is a y-intercept question. So they already kind of told you it was y-intercept. We're done. And she's already at soccer. You tell that coach. We've got SAT problems to do. You have a game. Oh, that's okay then. What a trooper. She's going to be chanting formulas as she runs. All right, next question. Oh, wow. That is a terrible fit line. I mean, can you guys just look at that? The scatter plot and this line? Whatever. All right, anywho, let's look. The scatter plot shows data for 10 charities along with a line of best fit. That is a terrible line of best fit. For the charity with the greatest percent of total expense. Oh, okay. Which of the following is the closest to the difference between the actual percent and then the percent predicted from the line? So they want me to find the charity with the greatest percent of total expenses on programs. So I got to kind of figure out where we're looking here. That would be this axis over here. So which charity has the greatest? So which one goes further up that axis? Do you find it? Isn't it this guy right here? And they want me to find which of the following is the closest to the difference between this and where the line is. Okay, well, need to do a little estimation, guys. That's why it says the best fit. Okay, so whereabouts do you think this is? 92, sounds good. And then if you figure out where it is on the line, so you have to drop it down to the line, how high up would that point on the line be? Yeah, you can say 85, it's fine. There's only going to be one that's even close, guys. If you find the difference between those, what you got? 7% off. The answer is B. That was a bit tricky because you had to kind of read what they wanted. That's not usually something we ask you to do too much of. All right. Next two are all referring to some really cool formulas. Oh my. You know, you learn something every day. I didn't know this was a thing. Mosteller's formula and Current's formula. So they are using these formulas. They're used in medicine to estimate the body's surface area of infants and children whose weight ranges between 3 and 30 kilograms and whose height is measured in centimeters. So, okay. All right, let's look. Based on Current's formula, what is W in terms of A? So this is just strictly like a little algebra manipulation question. So go up to Current's formula, this guy, and you need to solve for W. Can you tell that's where all the answers are? So isolate W for me, guys. Your first step would be to multiply by 30, and then real quick, we're going to subtract the 4 over. So I'm looking for 30A minus 4. Find them, there you are. Boom. That was a quick question. Yay. I bet the next one will be more fun. Let's find out. So those same formulas, if they give the same estimate for A, so we're going to set them equal to each other. That's what that means. They're going to be equal to each other. Which of the following expressions is equivalent to the square root of K, or, HW? I don't know, but I think we'll find out. All right, here, we're going to set their formulas equal to each other. So Mosteller, square root of HW over 60. Oh, this won't be bad, guys. Equals 4 plus W over 30. Now, guys, all they want you to do is find this. Isolate that. You only have one algebra move to do. What is it? Multiply by 60. Now, you do have a little bit of thinking to do because this is a quantity, right? You have 60 divided by 30. I need you to use your little reduction skills here. What is that going to reduce to? It's a 2. So the square root of HW is equal to this expression, which I think we're done, isn't it this? That wasn't too bad. That was fun. They had you manipulating twice. Cool. All right. So this is the point in the test where you're looking at your bubble sheet, because, you know, you'll have a bubble sheet in front of you you're bubbling in. And remember, we already did the gridded response at the beginning of the test, and we're like, okay, I'm approaching the end. It's going to get bad. They're not all going to be bad, okay? I don't want you to approach these with a bad negative Nancy attitude. Here we go. Total protein and total fat for 8 sandwiches. Okay. And you're probably really hungry now, too. Just keep that in mind. It's going to be about 12 o'clock when you take this test. You don't get food until 1:30. I mean, you get a snack, but I'm going to be starving. She's got her jelly beans ready. Well, don't bring them to the test. You're going to get yelled at. Okay, so we have a scatter plot that shows total protein grams versus total fat grams, yada, yada. The line of best fit of the data is also shown. Yes, I've noticed. According to the line of best fit, which of the following is the closest to the predicted increase in total fat for every increase in 1 gram of total protein? That's a really fancy way of saying what's slope. So, can we figure it out? Well, clearly it's positive, but so are all my answers, so that's not very exciting. Whoopsies. And you want to be looking at the line and not the scatter plot, because it says according to the line of best fit. So, I'm just going to pick my favorite 2 numbers that look like I can maybe figure out what they are. I'm just going to go here. And I'm going to figure out rise over run, and then we'll be done. So, this ordered pair, can you kind of tell that it's at about 15 high? Are you okay with that? So this is, like, if I want to give it an entire ordered pair, if you must, can you give me an estimate for how far over and how far up it is? Like, I don't know, I'm just going to make up an 8 because I'm not real sure on that, but 8, 15, are you okay with that ordered pair being 8, 15? And then this ordered pair right here, again, I'm just kind of making it up. But I'm going to go with like 22, oh gosh, I wrote too big. Can we go with like 36? Again, I'm making it up, but guys, the way this works, there's only going to be one answer that's anywhere around the right answer. So slope would be rise over run, so it went from 15 up to a 36. How high up are we? How much did it rise? Waiting for you to subtract it because I don't trust my subtraction. Is that 21? Okay. Thank you. And then how far did it? I can't hear you. I'm sorry. All right. Did you think you were wrong? Oh. Well, me neither. All right. So 8 to 22. How far did it run? 14. Okay. And then, you know, by this point, you're totally out of brain energy juice, so you just hit math enter enter, because let's just suck it up and hit a math enter enter. Oh, actually, don't even do that. Just type it in. They want a decimal. I'm sorry. Is it 1.5? Cool. And wasn't it exactly 1.5? I think that means I deserve like a gold star for estimating properly. Go me. All right, 22. Oh, look, another table. A survey was given to residents of all 50 states asking whether they earned a bachelor's degree or higher. My pre-calc students, and I think also my Algebra 2 students, may have seen this question in the last few days, so don't spoil it. These are 7 states data, some random 7 states that they're talking about. And then if I keep reading, it says the median percent for all 50 states is 26.95. So the question... and they did it to me again. It says, what is the difference? So I'm going to like circle the heck out of this so I don't forget what I'm trying to do. I need to find the difference between the median of these guys versus the median of all 50 states. So now I have a different challenge, and that's, I have to remember what median means. What's median? The middle number, which usually you guys would list them all out and start hacking away beginning to end. I don't really have time for that because I'm about to run out of time. So talk to me about who's the smallest number in this list. 19.5. Okay, who's the biggest number in the list? 36.4. Okay, who's the next smallest? 21.9. Who's the next biggest? 35.5. Next smallest? 25. Next biggest 30. There's your median. But that's not the answer they want. They want the difference. Oops, 0.9. From that median that you just found to the median that they gave you for all 50 states. Is that 0.95? You got a calculator, guys. I'm not asking you to do it mentally. Like, literally, this is, you have to remember where you're going to be at this moment, guys. The very end of your math test on an SAT testing day. You are going to have, like, You know how like in your car, you're on empty and you're like, oh, please make it home. This is our moment. Please, please, please make it home. You do the reading the reading language part first. Yeah, there's a few hours of reading in that, and then you have math for a few hours, and then you have an essay at the end. Yeah.
Why did they do that? Yeah, why
well,
does the problem have to be extra to pay for that?
Be extra. It's good. It's good for you. I mean, they're paying for it, so just. Yeah, you will. So all those plans, well, y'all were excited. You're like, oh, we're going to get out of school early. I'm so excited. You guys want to go to Panera after? No, you're going home and you're sleeping. I already know. I already heard the kids. They're like, you guys want to go do something after? And I'm giggling because I'm like, you're not doing anything. You're going to sleep. You're probably going to be sitting in your car the whole time. You're not even going to make it out of the parking lot. Like, forget it. I'm done. Oh, boy. You poor children. I feel so bad for you.
I feel like if I passed high school, one test should not determine my career.
Well, it's not going to necessarily. You can always take it again. Right. That's true. You got other options. Just you could take the ACT. You could just drop out. Oh yeah. Hi, internet. All right. Let's talk about cylinders, people. All right, the cylindrical can containing pieces of fruit is filled to the top with syrup before being sealed. This is need-to-know information. The base can have an area of 75 centimeters squared. The height of the can is 10. If 110 centimeters cubed cubic centimeters of syrup is needed to fill the can to the top, which of the following is the closest to the total volume for the pieces of fruit? This is a good old Eureka displacement question, eh? Oh, get it. Let's talk. You know, I'm going to call bad move on their part. There's been an awful lot of food questions at the end of this test. And I feel like that was rude. Because everybody's taking this test in the middle of lunch. What are you thinking, SAT? Okay. So let's talk about the volume of the can, because I don't think you actually have the volume of the can yet. How do you find the volume of a cylinder? If you forgot, it's on your formula sheet. It's area of the base times the height, which is pi r squared times height, but I think they already kind of told you the area of the base, huh? So it's 75 times, watch your labels, make sure nothing's weird, times 10. So the volume of the can, the entire can, is 750. Okay, I think we're done. The syrup, to kind of top off the can, is 110. So I think we just need to do this. Is that an answer? Please be an answer. Yeah, see. They did the what? Oh, they did! Oh, jerks! Oh my gosh, they did it. 750 right there. Oh, that's really mean. But now I want fruit in a can. And what was the other food about? It has to be in a can. That's where I'm. That's a good point. Let's go get some actual fruit. Okay. Oh, their second favorite function. We have a quadratic function. Now, this in particular, this is a quadratic function that is launched. So this is that same one we keep seeing. Negative 16t squared plus 110t plus 72. So you're supposed to remember what this means just from memory, but if you don't, we can kind of figure it out. But do you guys remember what the 16 is in this formula? It's always negative 16 in these formulas unless you're measuring in meters for some reason. This is the acceleration due to gravity in feet per second squared. So it's always, gravity on Earth is always the same thing, right? And then this number right here is the initial velocity that the object is launched at. So apparently this thing, whatever it is, was launched at 110 feet per second. And then this number right here, if you want to think of it as, it's the y-intercept of, well, it's a little confusing right now, but this parabola is going to look like this. So that last number, the c value, is the initial height. So back in algebra semester 1, you guys did 40,000 of these questions where you kept like launching things off of the tops of buildings, remember? Yeah, same stuff. So I think we just answered our question. They want to know what 72 represents. It's the initial height where it was launched. Let's see. So the initial height. Boom. Ta-da! All right. Again, with the fat and the protein and the carbs. Why? My goodness. Maybe the person writing this test was hungry. Maybe that's what's happening. Okay. So, where are we at here? We have a table of energy, grams, food calories, kilojoules. This feels very chemistry. Oh gosh. Okay. If X food calories is equivalent to K kilojoules, of the following, which is the best representation for the relationship of X and K? I don't know. Okay. All right, guys, let's compare. Let's compare two of them. Do you have a favorite pair that you'd like to look at? Fat, protein, or carbohydrates? Protein. Oh, I heard protein first. I'm going with it. Protein's good for you. I have a... All right, so let's compare these. I already forgot what the question is. All right, X food calories is equivalent to K kilojoules. So, geez, I keep forgetting. Oh, I keep flipping. X food calories, so X calories is K kilojoules. So if I kind of finish up that proportion using your protein information, food calories of 4 and kilojoules of 16.7, and I again forgot the question. They want me to figure out which one of these is representative of that. So here's what I notice. They solved for K twice. Let's quickly solve for this mystery K. Can you guys rearrange this proportion with me? So this would be 16.7 X. And then what's your last step to solve for K? Divide by 4. So quick little math problem for you, because I think we need to simplify that. What is 16.7 divided by 4? Excellent. I think we're done. Isn't that one of them? Yeah. There, you could have done any of them, yeah. It would have been fine, because they have a constant relationship, right? Because they didn't say anything weird, right, about protein? Right, so we would have set up a similar proportional relationship and rearranged it the same way. Very good, yep. I mean, I'm assuming. Otherwise, that would be a big lie, that table. And it might be one of those, which of the following is closest things. They might not have come out to exactly 4-2. Okay. More food. I'm so hungry. Like, I really am hungry.
Wait, for that one?
Yeah. Did it not work out?
Food calories is X.
Yeah.
And then kilojoules.
Yeah. I could have screwed it up. It happens.
No. So you're multiplying 4.2. Okay, never mind. You're right.
We're okay? Okay. Good. It wouldn't be the first. I don't think I've made a single video without a problem. So don't let this be the day. I have talked a lot. All right, 26. 180 food calories in a granola bar. Oh, so hungry. Comes entirely from P grams of protein, F grams of fat, and C grams of carbohydrates. Which of the following expresses F in terms of P and C? I don't know. All right, let's go back. We need to look at this food calories menu thing. Now, I'm going to have to keep flipping, so can you guys... Oh, you have to flip too? Oh, I hate when they do that. All right. Talk to me about setting up protein. How many food calories come from a gram of protein? 4. Okay. So 4 proteins plus, what's the next one? Fat. How many fat? 9? And then 4 for carb. And it's going to add up to a total of 180 food calories. So what you guys need to do is to isolate F. Man, there's been a lot of manipulation on this part of the test. My goodness. All right, so in order to isolate F, I'm going to peel away these. I'm going to subtract 4P and 4C over. So like this and this are going to get subtracted over here. And of course, we're going to have to do more work because that just would be too nice. So we have 180 and then a minus 4C and a minus 4P, either order. And then mathematically speaking, normally I would just tell my kids to divide everything by a 9, which is totally true. However, as I look through my answer choices, none of those look the same. So here's what we're going to have to do now. You either have to manipulate your answers to look like your answer, your choices to look like your answer, or you got to go back to the drawing board and manipulate your version to look like one of theirs. So personally, frankly, I'm thinking it wouldn't be that hard to, you know what, I'm going to live my life over again. Can I just divide each of these by 9 like this? Because this is 20, right? Which is how they're getting this 20. And then I think we're done. Do you guys see it? Now be careful. This right here versus these guys right here. They have a negative sign that's been, like, in our version, it's been distributed into it. So what happens when you factor that negative sign back out of that expression? These become pluses, right? So if I take a negative sign out, so one of these two, the inside becomes plus. So it's this answer right here. Blech. I'm sure you have the mental energy for that problem, right? Totally. Okay. Hoo, 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 27. You know, what are the odds of them putting a nice easy one here at the end? Not good. Okay. 27. Here we go. The world's population has grown at an average rate of 1.9% per year since 1945. There were approximately 4 billion people in the world in 1975. Oh my gosh, guys, this is a question over... Oh, they got crazy. This is not linear. When you grow as a percentage, you're looking at an exponential growth formula. Do you guys remember doing this in algebra and in pre-calc? Something like that? Exponential base. So this number right here, when you guys were doing word problems, is always the original amount. So if they want to have it in terms of billions, and we started with 4 billion people, we're going to be looking for an exponential function with a starting value of 4. Bummer, they both have starting value of 4, but talk to me about why the answer is A and not B. We're growing at 1.9%. What decimal is 1.9%? 0.019. Do you guys remember this formula? This base value, this guy right here, is really 1 plus the R. So 100% and then growing 1.9% is how they're getting the 1.09%. So that's kind of a really cool question for Algebra 2 kids, because we didn't do that question. I mean, it hasn't been that long ago. Pre-calc, you haven't seen that in a while, but exponential growth and exponential decay is original amount, and then it's either 1 plus the growth rate or 1 minus the decay rate, okay, to the t power. That's what makes it exponential. Okay. What do you want? We got a line. And it's, okay, it says a point not shown with coordinates st lies on that graph. Cool. S and t are positive integers. What is the ratio of t to s? Now, I don't know about you, but I was reading this and I was like, that's curious. They're like, the point not shown, and then they show you a point. Like, are you okay if I just pretend like that's the point they're talking about? Because essentially they're asking about slope, or the reciprocal of slope if it's a rate. So, I mean, are you okay if I call this s and this t? So the ratio of t to s would be 6 to 3, which reduces to 2 to 1. We're done. That was the world's stupidest question. I love that. It's a point, but it's not shown. It's absolutely not shown. Whatever you're thinking, it can't be that point. All right, you're packing up. Is that because you're done with me?
We only have 2 problems left.
We do only have 2 problems. I'm going to keep going. If you got to go, you go, guys. But let's see if I can go fast. Oh, it's a circle. Oh, we love circles. Oh boy. Okay, bad news. This circle is going to require me to do a little sketch. Now, those of you who've never seen my sketches of circles, you're in for a treat. Where is this? Hey, where is the center of the circle? Very good. -3, 1. Oh, God. My pen's not going to work. Okay. -3, 1. Right. It's like, no, I won't do it. What's the radius length? 5. Good, good. So, here we go. Center at -3, 1. Totally going to do this well. I totally am not. It's okay. And then your radius, go north, south, east, west, 5 units. So I should have drawn a little better than this, but whatever. 1. Oh, man. Okay, here's what I'm going to do. I'm going to pretend, and I'm going to label my points, because I'm a good labeler. Unless my pen doesn't work. See, it doesn't want me to graph it. It's like, no. All right, so pretend we're up 5, and we're, you know, like, that's not even right. Down 5, and we're going to be, like, right 5, and we're going to be left 5. And I'm going to have this circle, which I'm not even going to graph because you're going to laugh at it. So tell me about where these ordered pairs are. This is the ordered pair, -3, comma, if you were at 1 and you went up 5 units, now you're at 6. This guy over here was at -3, but it went right 5. So that would be at 2, comma 1. This guy down here would be at -3. It was, remember, up at 1, but it moved down 5, so -4. And then over yonder here, we got -3, comma, no, it's not. It's -8. Oh boy, -8, 1. And yep, what do they want, by the way? I've been so concentrated. Oh man. That was probably one of the best freehand ones I've ever done. I just want you to witness that. Thank you. Thank you. Negatives, they want to know which, oh, they did it. They almost caught me. I was going to do the one that was in the circle and not the not one. Okay, so which one is not on the interior of the circle? So -7, 3. Oh, I don't know. I didn't graph well enough for that. You're totally certain it's inside the circle?
Well, you do go to -8, 1.
Right. I mean, I didn't graph very well. I'll trust you. Okay, -3.
Yeah.
-3, 1, totally there. Okay, yeah, 0, 0, totally there. And 3, 2. That's the problem. 3, 2 is not in the circle. So, yeah. Now, there's other algebraic ways to kind of plug in and test. It's a little more complicated, though. Believe it or not, drawing was the way to go. All right, one more. We got this. Oh, gosh, I wrote the word nasty on it.
Oh,
Oh, boy. But we can't stop because it's the end. All right, the manager of an online... Hey, what are you going to guess if you're just out of steam time? What's your guess? Oh, that's not right. Okay. The manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 14. How many subscriptions did the manager expect would be sold in 2014? I don't know, but they discussed something called percent increase, so we should probably start investigating that. So from 2012 to 2013, the way you find percent increase is you take the difference between them and you divide by the original. So the difference between these, I'm so happy we have a calculator because I'm totally done doing mental math. Can you subtract those for me? 280, right? And then you divide it by, right? Yeah. And then divide by the original. So for time, that would be the earlier time. So 5,600. Can you guys tell me what that comes out to? 0.05. Cool. So it increased 5%. Now, read carefully. It said the manager estimated that the percent would be double. So to go from 2013 to the projected 2014, what would be double that, by the way? So 10%. Yep. So I need you to increase 5880 10%. So think about that sales tax question. If you're going to bump something up 10%, couldn't we multiply it by 1.1? That would be like all of it plus 10%. All right. Oh, wait. No. No, guys, I didn't do that right. Because I can't read. Read more carefully, Abruzzo. The 20, see, this is why I wrote nasty on it. 2012 to 2013 would be double the increase from 2013 to 14. So this is the bigger increase. The next year he's projecting a lesser increase. So this was the doubled one, so I need you to half it. Come back and half it. 2.5%. All right, that's what we have to do. So 5880, and then that needs to be increased by 2.5%. That's the answer. And I can guarantee you the other answer was right. The answer is B.
my guess is great.
Did you go B?
Oh, yeah.
B's my letter. That's mine too. B's
Josh
mine.
told me if you ever you're seeing.
That's true. For math, the middle ones are great guesses. I know, but it's a 50-50 shot at that point. I'm sorry. Tapping out.